So now let's dive into some examples. The first question we have is asking us if we pulled one card out of a deck, just at random, shuffled them well and pulled out a card, what would the chance be that our card is either a king or a queen? So, like we were talking about with the addition rule before, we want to add the probability of getting a king to the probability of getting a queen, because we're basically expanding our odds. We would be satisfied with either a king or a queen. So we have more options, so we're going to have a higher probability. So we're going to think about this as the probability of getting a king plus the probability of getting a queen. And then remember that we have to subtract the probability that our card is both a king and a queen. Now step back for a second and think about your deck of cards. Is there one card in the deck that fits both of these categories as the king of queens or the queen of kings? No, right? So this one, in this case, these are two separate entities that cannot be seen together at the same time. So this portion doesn't apply to this example. We don't have overlapping circles here like we did before. There's kings, there's queens, you can't have both. So our question is a little bit simpler than we had expected. So first we're going to find the probability of getting a king. Well, first think about our deck of 52 cards. There are 52 possibilities we could have picked. And how many of them satisfy this criteria of being a king?
4.
4. There are 4 kings in a deck of 52 cards. Good. And then the probability of getting a queen, the same idea. We still had 52 possibilities and only 4 queens in a deck, so there are 4 cards out of the 52 that satisfy this option of being a queen. And now we want to add these probabilities because we're concerned with getting either or. So we're increasing our odds, increasing our likelihood, so we're going to add these probabilities to get a final answer of 8 cards out of the 52 cards in a deck would fit this likelihood of being a king or a queen. So we have an 8 out of 52 chance. So let's move, yes, do you have a question?
Well, should we leave it in that form, or is it okay if we leave it in that form, like on the exam?
Either way, I think that it is easier to understand what you're talking about when you leave it just like this, because you can simplify it, but this makes sense that there are 8 kings or queens out of a deck of 52. So you can leave it like this. On an exam, we wouldn't mark you wrong if you were to simplify it, or if you were to put it as a decimal. The math is the same, the probability is the same, it's just different ways of expressing the same probability. But generally, I like this because it's easier to check your work and make sure that you understand. Sure, there are 8 cards in a deck that are kings or queens out of 52 cards in the deck. Makes a little bit more sense, a little easier. But the easy answer is we won't mark you wrong if you simplify. So now, moving on to the next problem is a little bit more complicated. So we are asking, what is the chance if we still just pulled, well, we got one roll. We're not rolling die here, right? On one pull, if we pulled out one card out of a deck, what's the chance that this card, this one card, is either a king or a diamond? So we're going to use this same idea that we were talking about before. First, we want to find the probability of getting a king, and then we're going to add that to the probability of getting a diamond, and then we need to subtract this both idea, the probability that this one card is both a king and a diamond. So when we think about our deck of cards, we have in our deck, we have 4 kings, right? And in our deck of cards, there are 13 diamonds. Diamond is a suit. So we have 13 diamonds. And you'll see that I've drawn these circles to overlap, so that there is, in our deck of cards, there's one king of hearts, there's one king of spades, there's one king of clubs, and there's one king of diamonds, right?
Oh, yeah.
So there's one card in our deck that fits both the criteria listed here, that we would count as a king, and that we would also count again as a diamond. So this is where this formula is going to really be useful, that we're going to want to subtract this card that was counted both as a king and as a diamond. so that this one card doesn't basically get counted twice. So let's go ahead. Does that make sense? Okay, so let's dive in and figure out the answer to this problem then. First, we find the probability of getting a king out of our deck. So again, there are 52 cards that we're pulling from, and 4 kings is 4 out of 52. Our probability of getting a diamond, now this is, kings are, a face card or a number card, where there's 4 of each. But diamonds are a suit. So out of 52 cards, there's always 13 of each suit. And now, so we're going to add those probabilities together because we want to increase our likelihood, right? We're increasing our space, our options that we'd be satisfied with. And now we want to subtract the probability that we've yanked out the king of diamonds, that card that satisfied both of these before. So out of our 52 cards, how many cards in that deck fit both as a king and a diamond?
Just one.
Just one. There's only one card in that whole deck that can fit both of these categories, right? So then we're going to add those together. We're going to do 4 plus 13, that's 17, and then minus 1 is 16 out of 52. So our final answer is that we have a 16 out of 52 chance of getting a king or a diamond.